Welcome to class. Today we'll be looking at the topic preparation of standard solutions and titrations, an unfailing topic in the GCE exams. This is one of the topics always termed alternatives to practicals. Grab your jotters and pens. Let's go. Like I said, our topic is preparation of standard solutions and titration. And as our subtopic for today, we are going to be taking preparation of standard solution. That will be today's lesson. Let's look at the definition of a standard solution. What is a standard solution, or what makes a solution standard? A standard solution is a solution of non-concentration, a solution whose concentration is well known. The fact that you know the molarity or the concentration of a solution makes it standard. Now that we know the definition of a standard solution, what is the use, or what are the uses of standard solution? Standard solutions are used to determine the concentrations of other solutions, using the concentration of what we know to identify the concentration of what we do not know. We should note that not every chemical in the lab is used to prepare standard solutions. Substances used in the lab to prepare a standard solution are called primary standard. We are saying that a primary standard is the substance used in the laboratory to prepare a standard solution. If there is a primary standard, of course, we should have a secondary standard. But today, our focus is on primary standard since we are working with the preparation of standard solution. What qualifies a substance as a primary standard? It should be highly pure, meaning it should have a high purity rate. It should be very stable. It should have a high molar mass. It should not be hygroscopic or deliquescent. It should be inexpensive and have a very high molar mass and also readily available. Some examples of primary standards we use in the laboratory are sodium carbonate, sodium oxalate, sodium tetraborate, and potassium dichromate. Now, let's enter the chemistry kitchen, the laboratory. Imagine you are in the lab and you are asked to prepare a standard solution of 0.1 molar in a 250 cm cube volumetric flask. It's like your mother asking you to prepare 5 cups of rice in a size 3 pot. What are the equipment you will use, and what is the procedure you will follow? Let's dive into that. We have a case study on the board. Preparing a 0.1 molar standard solution of sodium carbonate using a 250 cm cube volumetric flask. Let's start gathering the equipment we'll be using or needing in preparing our standard solution. As I draw, you should be naming those equipment. That's the first one, the second now, the third one. I'm going to draw just the essential and just name the others. This first one, we have a balance. The second one, we have a beaker and a stirrer. What is inside the second one is a stirrer, and the cup-like one is a beaker. And then the last one, the one I'm holding, is a 250 cm cube volumetric flask. Other materials and chemicals we'll be needing are sodium carbonate, that's the salt we'll be using. We'll be needing a funnel. We'll be using distilled water to dissolve our salt. We are moving into the steps or the procedure followed when preparing a standard solution. The very first one, we are going to weigh the mass using a scale balance. Second, we are going to dissolve the weighed mass using distilled water. And the third, we are going to transfer the solution into a 250 cm cube volumetric flask. The very first step we saw in the procedure for preparing a standard solution was to weigh the mass. But what mass exactly are we going to weigh? Is it going to be 2 kilograms, 3 kilograms, or 4 kilograms? So what we are going to do now is to calculate the mass that's going to get into a 250 cm cube volumetric flask. When you are asked to prepare rice in a size 3 pot, you don't just go and carry a bag of rice and you're cooking into a size 3 pot. You need to know the cups that will be able to contain a size 3 pot. It is the same with molarity. We need to know the mass that will fit into a 250 cm cube volumetric flask. The salt we are working with is sodium carbonate. So to calculate the mass of the sodium carbonate that will fit into a 250 cm cube volumetric flask, we use the formula mass is equals to molar mass times molarity times volume. And the molar mass of sodium carbonate, when we calculate it, is going to give us 106. The molarity we are asked to prepare, or the concentration, is 0.1 molar. And the volume of the flask we are using is 250 cm cube. We are going to divide the volume by 1000 because this formula requires us to use the volume in cm cube or in liters and not in cm cube like we had. When we calculate the mass, we are going to have 2.65 grams. So that is the mass we are going to use, or we are going to weigh. We should note that the 106 is coming from the molar mass of sodium carbonate. The chemical formula of sodium carbonate is Na2CO3, and that's how we use to calculate the mass. 2 times 23 plus 12 plus 3 times 16. 3 times 16, not 26. Now we have calculated the mass we'll be working with. So let's look at the detailed procedure. First and foremost, we are going to be using a clean and a dry beaker to weigh exactly 2.65 grams of anhydrous sodium carbonate using a balance. Anhydrous means no water. Next, we are going to be adding 100 cm cube of distilled water into the weighed mass. The weighed mass is in the beaker, so we add 100 cm cube of distilled water to dissolve the mass. Using a funnel, we are going to transfer the solution into a 250 cm cube volumetric flask. We are using a funnel to avoid spillage so that some of the solution doesn't drop out, because we need every bit of it. Using distilled water, we are going to rinse our equipment, our stirrer, our beaker, and our funnel thoroughly, and we're going to add the solution into the volumetric flask. We will continue rinsing and adding the solution into the volumetric flask. When everything must have been well rinsed, we are going to use water from a wash bottle to make the solution up to the 250 cm cube mark. Now we are going to stopper our solution or cork it and turn it upside down to homogenize. Our standard solution is ready. Hooray! Congratulations! You have prepared your standard solution of 0.1 molar in a 250 cm cube volumetric flask. Now we await titration. In our next class, we are going to use our prepared standard solution to carry out titration. You have assignments at the end of this video to do. Make sure you do your assignments. That's when I will evaluate to really know if you have mastered the concept. It's been nice having you in today's class, and hope to see you again in our next class. Thanks for joining, and see you. Have a wonderful day. Bye-bye.